Hello guys, and welcome to another video. On this video we'll be looking at this table. It has to do with motion in one dimension. Okay, so let's get into it. They say here that the engineers at a car company conduct various tests on their cars. During one of the tests, they measured the change in position during equal time intervals. The results obtained are recorded in the table below. This is our table, and it's not our first time seeing this table. So by now we know that time here will be our independent variable and position will be our dependent variable. That's important information. Okay, now let's get into our questions. They say on 3.1, give the correct term for change of position per unit time. Change of position per unit time. What is that? The correct answer, guys, is going to be velocity. Okay, the correct answer is velocity. Okay, now we move on to 3.2. They say for this test, write down the independent variable. What is our independent variable? We've already said this, and the answer is going to be time, which is measured in seconds. Then we move on to the second one. What is our dependent variable? Our dependent variable, guys, will be what will be on the y-axis, which is position. Okay, and position will be measured in meters. Okay, now we move on to the second part. The second part says use the information in the table above and draw an accurate position time graph on the graph paper that is attached on the answer sheet. I do not have the answer sheet, guys. Now let me tell you something about this name here, position time. When you see this means that the first thing that is mentioned is your dependent variable. That means it's going to be on the y-axis. Okay, and the second mentioned thing will be your independent. It's going to be your independent, and this one will be on the x-axis. Always check that out. Whatever that is mentioned first becomes your dependent. The one that is mentioned second will be your independent, and the dependent will always be on your y-axis. Now let's draw our graph. Obviously our graph is supposed to have two axes. Firstly the y. Remember guys that I'm not using a ruler, so my graph will not really be that much perfect, but look at it, there it is, straight. Okay, why won't this one be straight, this line? Anyway, so we'll have our y-axis here, and here we will have our x. This is where we find our time. On the x-axis our time is measured in seconds, and this side will have our position. Position is measured in meters. Okay, then now we are going to put down our points or come up with our scale. We know here is going to be 0. Let's check out the x-axis values, the time. We start from 0 and end at 4, so we'll have 0, 1, 2, 3 and 4. Okay, now we'll go to our y-axis. What are we going to have there? 0, 1, 2. Our scale on the y-axis is 0, 5, 10, so we are going up by 5 here. So I'm gonna have 0, 5, 10, 15, 20, maybe I'll end up at 25. Okay, there is my scale. Then from there I check the first 2 points, 0 to 0. that is the origin. Y is 0 and x is 0. Second point, 1 2 5. This is my 1 2 5. There we go. And that point is 2 to 10. Here's my 2, I take it up to 10. There it is. You see, I'm just putting my points here. Then I check the other point, 3 to 15. Here is my 3. Let me take it to 15. This is my 15 somewhere here. There's my point. Then I move on to the last one. It's 4 to 20. Here is my 4. I'm gonna put it to 20. It should be somewhere here. There it is. And then from there I'm gonna join these points. Remember guys, I'm not using a ruler. That's my line is not straight, but you are supposed to get a straight line. I forgot another important thing in the previous video. Remembered it now, that we have to also guys give our name, our graph a name, and our name for the graph will be position versus time graph. That's all it is. Position versus time graph. That's it. Okay, so this is how you draw your graph guys. I hope it makes sense. Okay, let's move on now. And the second 3.4 says calculate the acceleration, the gradient of the graph. They say we must find the gradient. Guys, again, this is a position versus time graph. So what does the gradient represent here? This is what it represents guys. It represents the velocity. Okay, but let's unlike in the previous video, let's find our gradient using the gradient formula this time. So we'll have, okay, I almost said y, I was thinking y2 minus, but the gradient formula, as you know it, is going to be m is equal to delta y divided by delta x, which we can expand to y2 minus y1 divided by x2 minus x1. That is our gradient formula. Then from there we will substitute into this formula, check out our y1 and our y2. I'm going to use the first point here. I know here I have 0 and in fact let's do things differently now. Let's use these points here. Here I have 2 and 4. As you can see, 2 goes, okay, it's actually 2 that goes with 10. So I will have 2 and 10, and the other point I'm going to use is this one, which is 3 that goes with 15. That's my second point, 3 that goes with 15. Okay, now let's find our gradients. We'll label this one x1, y1, x2, y2. Now let's substitute. What is our y2? It's 15 minus our y1, which is 10, divided by our x2 is 3 minus our x1, which is 2. What is 15 minus 10? It's going to be 5. And what is 3 minus 1? I mean 3 minus 2, it's 1. So our gradient is actually 5 meters per second. That is how you answer this question, guys. I hope it makes sense. So our gradient in this case is the velocity, and the velocity, guys, is 5 meters per second. All right, now we move on to the penultimate question, 3.5. It says draw, not to a scale, a corresponding velocity time graph for the motion of the car. Label the axis. Okay, so if we check here, they are saying we must draw the velocity versus time graph, and this is the position versus time graph. But we know that this straight line gives us the gradient of the graph, which represents the velocity. What do we know about velocity when we are having a straight line like this, guys, on a position versus time graph? What we know is that our velocity is constant in this regard. The fact that we have this straight line on the position versus time graph means that we have a constant gradient, which means constant velocity. How is constant velocity represented? This is how on a graph. My graph will not be perfect, nor will it be big. So this is what I have. When I have my y-axis here, here I'm gonna have my x. On the x-axis, my time is what I have in seconds, and this side on the y-axis I will have my velocity, which is measured in meters per second. I hope you can see that here, guys. Then I'm gonna have up until 4 seconds. So here I'm gonna have my time. I'm starting from 0 up until 4, so I'm just gonna write 4. And that means for the 4 seconds that this car travels, the velocity is constant, and velocity that is constant is represented by a straight line like that. Then here I'm just gonna put 5 being our constant velocity, the one that we found here. Remember, we found this for 3.4. okay, so that's our constant velocity. I hope this makes sense. All right, this is our velocity versus time graph. Okay, this line that is straight or flat represents our constant velocity. Okay, now move on to the last question. It says, hence deduce the magnitude of the acceleration of the car. What do we know about the magnitude of the acceleration, guys? We know because our velocity is constant. What did I say about acceleration? If we have constant velocity, that means our acceleration is 0. So here when we deduce, we'll say that acceleration is 0. Let me just use weights. Acceleration is 0 due to velocity being constant. Then we are done, guys, just like that. Okay, remember that I've not numbered some of these questions, so just rewind and you'll understand which one is which. Okay, and like I always say, if you don't understand, please rewind. And guys, I'll be happy if you actually answer these questions before you see the answer. Attempt to answer the question first. Other than that, guys, please do like, subscribe, and share the video. I'll see you on the next one. Bye bye. Happy learning.